Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on pH and the pH scale. In our last lesson, we learned about the strength of acids. We discussed strong acids versus weak acids, and concentrated acids versus dilute acids. We also discussed some necessary precautions that need to be taken when dealing with acids. It is very important to remember to be safe when working with concentrated acids because they are extremely corrosive and poisonous. In today's lesson, we will define pH. We will determine if a solution is acidic, basic, or neutral based on its given pH label. We will also perform activities to determine the pH of some common substances. Students, if you are ready, then we will get started. Using the concentration of hydronium ion within a solution to express its acidity can be quite cumbersome. This is because the values are relatively small. Thus, pH is a much more convenient quality to use. The letters pH come from the French words pouvoir hydrogène, which directly translate as hydrogen power. pH is defined as the negative logarithm of the hydrogen ion concentration or hydronium ion concentration. It is mathematically expressed like this. The square bracket represents concentration in moles per liter. In order to calculate the hydrogen ion concentration of a solution from its pH, we can use this equation. There are a number of ways to measure the pH of a solution, including universal indicator solution, pH indicator paper, or a pH meter. Universal indicator solution is a blend of several compounds. It displays smooth changes in color over a pH value range from 0 to 14. It shows the acidity or basicity of solutions. Litmus paper does not display quite the range that universal indicator solution does, but it works on the same principle. When a universal indicator is added to acid solutions, it develops different colors depending on the level of pH the solution has. The standard color chart that you see in image A is used to determine pH, based on the color the solution turns when universal indicator is added. Image B is a pH meter. It is an electronic device that directly measures the pH of a solution, similar to how a thermometer measures temperature. The range of acidity and basicity, or alkalinity, is often expressed on the pH scale. As you can see, it has a range of 0 to 14. The middle of the scale, which is a pH of 7, represents a neutral solution. Solutions that have a pH less than 7 are considered acidic. The strength of an acid solution increases as its pH gets closer to 0. Solutions that have a pH higher than 7 are considered bases. The basicity of a solution increases as its pH gets closer to 14. Students, let us do an activity to make sure you understand how the pH scale works. Please answer the following questions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do on this activity? Let us answer these questions together now. For question A, acid 2 would be the stronger acid. For question B, solution 1 is a base, solution 2 is neutral, and solution 3 is an acid. Finally, for question C, 0 represents the strongest acid and 14 represents the strongest base. Let us move on with our lesson and learn how to calculate pH values of a solution. We will determine the pH of a hydrochloric acid solution with a molarity of 0.001. We know that hydrochloric acid is a strong acid and that it dissociates almost completely. When it dissociates, it produces 0.001 mole per liter of hydrogen ion and 0.001 moles per liter of chloride ion. The reaction looks like this. Therefore, the concentration of hydrogen ion is equal to 0.001 moles per liter, or a molarity of 1 times 10 to the power of -3. We can use this in our original equation. Thus, negative logarithm of 1 times 10 to the power of -3 equals 3. Thus, the pH of our solution is 3. Students, now we have gone through one example together. You are ready to try an activity on your own. The hydrogen ion concentration in a dilute solution of vinegar is 4.6 times 10 to the power of -5 m. What is the pH of the solution?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. We can start answering this activity using the mathematical equation for pH and add the hydrogen ion concentration of our solution to it. Therefore, the pH is equal to minus log multiplied by 4.6 times 10 to the power of negative 5. This eventually simplifies to 0.663 minus 5, which gives us the answer 4.337. Today, we discussed pH and the pH scale. We learned about different ways to measure pH, as well as how to calculate pH using mathematical equations. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.